Okay, hello everyone. Welcome to, I think this should be day 5 or 6 of our Power BI boot camp. And please don't forget that this boot camp was hosted by the, or is hosted rather, by the Winnipeg Fabric and Power BI user group. And we've been on some topics now for a while. Last week we started dimensional modeling, the concept of dimensional modeling, and our guest speaker did a good job explaining all the important concepts that you need to understand before diving into the practical aspect of things, right? Today again we have Astraf, who is the community lead for the Toronto Fabric and Power BI user. Is one of the biggest, in fact I think it's the biggest Fabric and Power BI user group in the entire Canada. So um we have him again. He's a Microsoft MVP. He's a Microsoft certified trainer. He has been in the field now for, if I'm correct, Astrap, more than 17 years, right? Or 20.
Yeah.
Yes. So he's well experienced. He has worked on a lot of projects. Somebody you are going to learn from. And please, if you have questions, don't be shy to ask questions. Ask your questions. Every day we learn. I can be in this class and you will still say some things that maybe I've probably not heard before, and I would learn something from there. In fact, there's no body that is bigger than learning. So please ask questions. If anything is not clear to you, don't be shy. We are all here to learn together and grow together. And I pray that at the end of the boot camp, we will share testimonies of how they were able to ace interviews, how they were able to answer interview questions, how they were able to get jobs. So thank you very much, guys. Astraf, you have the floor now.
Thank you. Thank you, Benga, so much. And thanks, everyone. Good morning. And thanks, everyone, for having me one more time. I hope you learned something in the previous session, and I hope we will continue actually what we talked about in the last session as well. By the way, being a small correction, Trono Fabric and Power BI is actually the biggest city-only user group in the world, and we are number 3 worldwide after the Philippine user group and India user group. And both of them, the first two, are countrywide user group and the hybrid user group. So in terms of comparison, we cannot really compare with any hybrid user group because our user group is just in-person only user group and only limited to one specific city. So I consider our user group is to be the biggest city only in-person user group in the world. We have more than 600 active members. Okay, great. So good morning again, everyone. I hope you enjoyed the previous session. So today we will continue actually the demo side, hands-on demo side of what we discussed last time. I'm not sure if we have any new members today, but I will do just a quick recap of what we covered yesterday. Then I'll give you a chance actually to ask any questions in case you didn't have a chance last time. Yeah, then we can jump to the demo. So that's my background. So I'll pass that. Like, as you know, I am the leader of the Toronto Fabric and Power BI user group, and I'm Microsoft MVP. I have been Microsoft MVP for since 2018 now in data platform, particularly in Power BI and Fabric. And I'm also Microsoft certified trainer. So we talked in our previous session. Yeah. If you are not, if you are not, if you are not asking me question, please can you make sure that you are muted, please? So
Please, can you mute yourself if you are not the one presenting, please?
okay,
Sorry
thanks.
about that. Please go ahead.
No, that's okay. No worries. So we talked about the objective of the session, which is what is the purpose, is to introduce actually the basic understanding of the dimensional model and how to manage dimensional model in Power BI. we talked about different phases of building your Power BI report. We're starting with the get data phase, which basically you focus on the data manipulation, first of all, data profiling, data quality identification, data manipulation, data integration, using Power Query Editor. Then after that, you proceed with Power BI Desktop to build the model, the dimensional model, by identifying the facts and dimensions. And also after that, the third stage here is to enhance the model by adding DAX calculations and measures, because as you know, the data usually that we use is very granular, very transactional, and is not 100% ready for reporting yet, unless we enrich that raw data and transactional data with some aggregations and calculations and function using DAX. Then the last phase, of course, which what everyone is interested in and looking for, is the visualization stage, where you have the opportunity now to use the enhanced model to build all the fancy dashboards and charts, etc., in the visualization phase. We talked about like what is the data model. Basically is the collection of tables connected with relationships to enable the business users to easily understand and explore their data and navigate the data to get business insights. We also talk about the not every model is a good model. So don't be under the assumption that if you have a data model, that means it's automatically a good model, because unfortunately this is not true. And this is not the case. So some reports, they are based on poor data models, and some reports are based on good data models. So why it's important to have a good data model? Because it makes it available for reporting in a very intuitive way. It presents the correct numbers through calculations and measures. It makes the report design and use of visualization much easier. And also it improves the report performance, because as I mentioned earlier, if you have cumbersome data model behind your report, you may end up with joining so many tables, and that can impact the performance of your report and the interaction of your report. Also, it can make your DAX calculations and measures very cumbersome, and this can take longer time to interact with your report. And I'm assuming actually you got it correct, and the DAX measure, I mean. And if you deal with so many denormalized table, you may be having a challenge actually to write the proper DAX calculation measures connecting multiple tables, especially if you are new to Power BI and data modeling in Power BI, which can impact actually the accuracy of your calculations and measures. Assume that the calculation is good, but the price that you have to pay with dealing with poor data model is the poor performance and poor interaction with it. So as a result of having a good data model, and because of all the benefits we mentioned earlier, it increases the user adoptions, and it will make your Power BI report a successful report in your organization and be used by so many people in the organization because it's effective. We talked about different types of data models. We talked about the flat or denormalization, which is the majority of you are aware of, which usually comes from the Excel sheets. We talked about the star schema, and also we talked about the snowflake, which is the extension of the star schema, where certain dimensions are more denormalized and has a hierarchy within the dimension itself. So star schema quickly. Like why it's called the star? Because it looks like a star. We start with a table in the middle, surrounded by a bunch of tables around this table with a bunch of relationships. What is the table in the middle? Is we call it the fact table. The fact table, the purpose for the fact table is to capture all the business transaction and business events in the organization, the core operation. It could be a financial transaction, it could be inventory transaction, it could be a client service transaction, it could be a call center transaction, whatever the transaction is. This is our core fact table. And this is the logical home for all, or the majority, if not all, the business measures that we are interested in. All measures around the sales, the counts, the averages, the min and maximum, etc., technically can come from the fact table, because that's the core transaction of our business. Yeah, so as you see, like that's the logical home for business measures typically. Also, this table is surrounded by, or the middle table is surrounded by a bunch of tables. We call them dimensional table. And the dimensional table, what is the purpose of the dimensional table? Is each single dimension is responsible for a logical entity within the organization that deals with the particular attributes to classify our data further. That can allow us to also filter the data and get a narrowed down subset of the fact table using those dimensions, one dimensions or multiple dimensions combined. And also the attributes in the dimensions or the column dimension can be also used to aggregate the data to a higher level. Okay. Typical examples here is the product dimensions where we have all the information about the product. No need to repeat 10 different columns about every single product with every single row for that product in the fact table. And instead of wasting our model space and repeating the same information over and over again, thousands of times or millions of times for every single time that this product was used, we push this information to a separate dimensions where we have a list of unique products that we deal with. Could be hundreds of products only, while the fact table can have millions and trillions of records. Hundreds of products in the product table, and every single product is listed once, unique record for every single record product, and all the attributes that describe the product is in the same table. Another example, again, customer, where all the information about every single customer is listed once in the customer table, no matter how many transactions this customer is associated with in the fact table. Location, promotion, etc. And as you see, the dimensional table are responsible for providing us the key answering for those key fundamental questions. Who, what was sold actually, which product was sold, top 5 product, etc. Those questions can be answered with the combination of the product table and the sales table. To whom that was sold, this product, that the customer table comes to play here, because you can get this answer from the joining customer table with the fact table, and you can rank the customers based top 5, top 10, etc. Where this transaction happened, or where was this product was sold, in the location table, where you can get all the information about the locations, and you can roll it up to from a very transactional level, granular level, depends on the level of granularity of capturing the location information in the fact. But let us say the location information captured in the fact table at the postal code level. Then now joining that transactional table, the sales with the location table, you have the opportunity to aggregate the data to a neighborhood level, a city level, a province level, a country level, etc. So you get all this information, hierarchy here for this location that come from the location table, and so on. Also, as we mentioned, all the association between the facts and DIMs are driven by a relationship. And the relationship basically is putting the primary key from the dimensional table as a foreign key in the fact table. That's the association. So every single record in the sales table as a fact table is associated with every single dimensions around the fact table. So you have a foreign key for the location, you have a foreign key for the customer, you have a foreign key for the product, you have a foreign key for the salesperson, you have a foreign key from the promotion table inside the fact table. That's the association that we built. Every single dimension has a primary key. So the foreign key I mentioned earlier in my statement is technically the primary key from the dimensional table, where it's unique in the dimensional side. It's one record only for every single ID in the dimensional table. While in the fact side, we can have many records associated with the particular customer, or many records associated with a particular product or a particular location, and so on. So the typical relationship in the dimensional model or the star schema model inside Power BI is 1-to-many or many-to-one. It depends on where you read the relationship. So if you read it from the dimensional side to the fact side, we call it 1-to-many. Like a customer has 1-to-many relationship with the sales table. The product has 1-to-many relationship with the sales table. If you read it backward, the sales table has many-to-one relationship with the product table. The sales table has many-to-one relationship with the customer. So 1-to-many and many-to-one, it depends on the direction of the relationship. We also talked about the 1-to-one relationship. and which is basically every single table has one record associated from table A has one record associated in table B, and every single record in table B associate the one associated record in table A. And as I told you last time, if you come across a situation where we have one-to-one relationship between any tables in your data model, that strongly suggests to merge those tables together and combine them in one logical table, because technically they belong to one logical table, because one record here and one record there. That means what? That means it's one record, but it's long enough. It happened that it comes from two different tables, because those two different tables can come from completely two different systems. And now our opportunities now in our model building stage in Power BI is to simplify, as I told you, and minimize the number of tables as much as we can. Therefore, if you have a one-to-one relationship, that strongly suggests, as I told you, to combine those together and create a bigger table with all the column from table A and all the column from table B, and just have one record in one consolidated table. Also, we talked about the other exceptional type here of the relationship, which is the many-to-many relationship. As we mentioned also last time, it's problematic to have many-to-many relationship because it cannot be physically implemented inside Power BI, because it can create duplications automatically by design. Because as I said, to build a relationship, you have to bring the primary key as a foreign key in the other table, right? And if we have logically many-to-many relationship between two different tables, if you bring a primary key from table A and put it as a foreign key in table B, it will create a duplication right away. And if you bring the primary key from table B and put it as a foreign key in the table A, it will create a duplications as well and violate the uniqueness nature of the table. Therefore, we said that also the solution for that awkward situation is to break down the many-to-many relationship to one-to-many relationship and many-to-one relationship by introducing an intermediate table to break this many-to-many relation, the logical many-to-many or conceptual many-to-many, into a physical many-to-many relationship by introducing intermediate table where we break down this relationship. So we introduce intermediate table where table A primary key is a foreign key in this intermediary table, and the primary key from table B is introduced as a foreign key in the intermediary table. And in the intermediate table, we can have a chance actually to include more additional attributes that is related to this interaction between the records from table A and table B. We talked about one of the classical example here is the relationship between a student and the course, student table and the course table. Every single student has a one record in the student table, and every single course has a one record in the course table, right? That's how it works. If you bring the student ID to the course table, it will create a problem, because it will, what if one student is associated with multiple courses? That will create a duplication in the course table. What if you bring the course ID as a foreign key in the student table? That will be problematic too, because what if we have multiple students in one course? So the only solution for this awkward situation is to introduce an intermediary table where the course ID and as a primary key from the course table and the student ID as a primary key from the student table can bring them together into intermediate table. And this table can technically be called enrollment table, where we have the association between the course ID and the student ID. And also, we can have a chance to add more attributes about this interaction or this relationship, like the course start date, the course end date, the delivery method, is it online, is it in class, etc., etc. So all the additional attributes, we can start capturing them in the intermediate table, which is the enrollment table in this example. So that's it. So as again, a quick recap here for the phases again, this is actually the area or the stage where we need to focus our effort about building a data model. And after that, you enhance and reach the data model using DAX. I hope that was a quick recap and in a very short time. Now, do you guys have any question about the concept before we jump to the actual demo, how you create a dimensional model if you happen to have a data or have access to the data that is not dimensional model by nature. It comes as a flat denormalized table in Excel. Any question, which is basically the flat or denormalized, how to convert the flat or denormalized data to become a star schema dimensional. That's the purpose of the demo. But before we jump to the demo, any question about the concept of dimensional model and the star schema? Don't feel shy, guys. Go ahead.
Could you please adjust your speed like last week? Thank you.
Sorry, say it again.
Yeah, I mean, could you please adjust the your speed of
the speed of
your
okay.
presentation? Yes.
I'm so sorry. Okay.
Thank you.
Yeah,
No
thanks.
worries. No worries. Thank you.
Thanks for reminding me. I appreciate it. But is there anything about the concept? Because that was meant to be a quick recap of what we covered already in our previous session. So I went so quickly because I don't want to waste longer time and repeating the same exact session one more time. But if you guys are still struggling with any of the concept, let me know so we can deep dive into any part of what I just explained now.
Yeah, a quick one.
Yeah,
a
sure.
copy of this last presentation, maybe in a summarized version or whichever one works for you and the team. Thank you.
Okay, I will. Any question, guys, first before we jump to the demo? Okay, cool. So here, I have a data here. Let me switch to the data view in Power BI. So here we have like a sample data. It's a sales data, okay? And as you see, from a modeling perspective in Power BI, I just have one table, right? What model is that, guys? Based on what we explained earlier, what kind of model is that? It's a very long table, of course, because it has so many columns. What is the data model here in this report? If I continue working with this report using this data set, what is this data model name? You understand, remember the 3 different types of data modeling? If we just based our table based on just one denormalized table, what is the data model here? It's a flat or denormalized table. That's the basic one, simple one. That's exactly that we will
I
be
think some
working
people
on.
are responding in the chat section.
Sorry, say it again?
Some people are responding to you in the chat section.
Okay. Yes. Oh, okay. Sorry, I didn't pay attention to that. Okay. Yeah, please come off mute. Let's have this session as an interaction session, please. Okay, cool. So let us zoom in and deep dive into this flat table. So, and that's the typical process, right? We need to get sense of our data. So let us go through it together. This table is obviously a sales table, and what are the columns there? Sales order ID, we have country, we have order date, we have channel code, we have product ID, we have a style name, we have customer account, we have account number, we have a store key. Let's open because what I see is mainly null values. Let's see if we have any values in this table. Oh, okay. So yeah, some of them are null, some not. That's good. So let us keep it because if we have one column across the board is null, it's useless. We have to get rid of it because it doesn't make any sense to keep it inside our report. Okay. Then we have a product label, a product description. We have manufacturer, a brand name, a class, color, stock type, units, sales amount, satisfaction score, or satisfaction label, which is basically low and high. We have subcategories, categories, small size, or sale size, sorry, product name, sales size store, unit cost, unit price, sales tax, rate, purchase again. Okay, cool. So that's lots of information actually about our data, right? In just one table. And as you see, this is exactly what I was trying to explain to you earlier, guys. Like, as you see, so many transactions here, we repeat the same information over and over and over again, right? Manufacturer, how many times the manufacturer is listed here? Brand name, also. How many times the same exactly brand name is repeated? How about class? See how many classes are listed there? Color, stock type. So how about the subcategory? See, so many records listed the same exact subcategory over and over again. Category as the same. Product name. Of course, this is not sorted by product name, but what if we sorted by product name? Sort ascending and see. So how many times the same exact information is repeated over and over and over again? Same exact information. Right? That's waste. That's waste of our data model. It's creating too much information that is not needed to be repeated several times. Okay, cool. So that means it strongly suggests actually to start to break down this one table and start to do some like split of this table to generate facts and dimensions out of this one centralized table. Okay. So based on your quick view here, can you put in the chat what do you suggest, or what could be the suggestion of some of the dimensions that can be extracted out of this big transactional table? And someone start to actually tell me what could be the suggestion for some of the dimensions as we explained earlier in the dimensional model, because
Okay,
it's a
I think I
mix of
see.
fractal dimensions. Yeah.
Think I say country, so we can say location, dimension.
Yep.
Okay, I see products ID, so we can have product dimension.
Or product
I see
dimensions.
customer. Yes, I see customer account number, something like that. So we can have customer
Excellent.
dimension.
Okay.
What again? I think if you can scroll to the right and we have okay. I see something on manufacturer, so we can have okay. I think that can still be under product anyway, unless we also want to further normalize it, but we can have that under products.
Yeah.
I see probably product category and subcategory. If you want to denormalize it, everything can be under the product table. Yeah, I think those are the ones that I can see here.
Yeah.
Class, country, customer, products, and we also need to have a date table that will
The
connect to
dimension
this.
is, of course, yeah, that's one of the
Yeah,
common
date,
dimensions that we have to
yeah.
create.
Yeah, so those are the ones that I can see. Maybe
You
others
can
can
see.
also contribute. Yeah.
Excellent. Okay, great. Anyone else wants to add something? I saw Amina in the chat. She said price table. Like, why do you suggest to have a separate price table? I mean, what is the price of what? Price of what? I mean, amount as a separate table. Also, amount of what? Like, can you elaborate more? Can you go off mute if you are okay?
Yeah. Hello.
Yeah.
Yeah. When I'm looking at the table, I am seeing unit price, amount, and probably price of the product. Yeah, maybe the cost of the product. That will be like the facts table. where you have the amount of whatever the product is with all the foreign key of the dimensions standing as a fact table.
Okay. But
And
do you
I
suggest
can
to have the
see
price as a table? You said the price table. Do you suggest the price to be a separate table? And why did you suggest that?
no, not precisely price table, like
Okay.
the fact table where the unit price of the product will be standing as the fact
Okay.
table.
Fair enough. Fair enough. That's good.
And
Okay.
I'm seeing store there too. Probably we can have a store where all the products, the manufactured products can, or the order table, what is ordered, the product that is ordered can stay with different, because there are subcategories table, the
Yeah.
color and type and stuff like that under the store, so we can have all those as well. Like, because we
Okay.
have a stock key which will comprise all the maybe some other subcategory products that is there.
Okay. Cool. Fair enough. That's good. Okay. And someone, Aisha, suggested also to have an order table that is an order ID. So order table, we have to think about that, Aisha, if we really need, or if we have enough column to separate the order header from the order details, or if we don't have enough structure here to do that, like the order table in our case is the same sales table. So it's the fact table. What you called it order table is the same fact table, where the order ID is actually the ID in this fact table. But that's great. So as you see here, it's a mix of different level of granularity here. Some of them are very granular and some of them are repeated over and over again. Like, for example, how many times the country is repeated, as you see, multiple times. Okay, so now that's the chance now to start actually making some segregation of and build actually the dimensional model. Where can we do that? Not here, because here, that's just the data modeling, visualization, calculations, etc. So the right way for us is we have to jump to our query editor. Okay.
Also,
Yeah.
I'm thinking about, I think I saw something like unit, maybe quantity.
Quantity. So where do you suggest to have the quantity?
Yeah, probably we are having a unit of whatever product, maybe 2, 3, 4, in terms of the amount, would I say quantity of the product.
Yeah, but quantity, where do you want to capture the quantity? Is it factor dimension information?
Okay.
Is it
part.
factor dimension? Where do you suggest to capture?
It can be part of the fact as well. We can have another, maybe two fact table where we'll be talking about the quantity of the product in terms of number. If the unit price if we have to create another key for the quantity, probably will be standing as a quantity table if we don't want to mix it with the amount of the products in the sales table.
Quantity cannot be a separate table, of course,
Okay.
because quantity is associated with the sales transaction. It's basically in the sales transaction table is telling me from this product how much quantity was sold in this particular transaction.
Yeah.
So it's a fact information. Actually, it should be kept in the same fact table.
Yes, Dave. Okay. Thank you.
Okay,
That's
cool.
good.
Okay, cool. Okay, guys, that's really great. So let us now start actually from this table, as you see here. Let us do some quality check here and some profiling check as well, and see whether our understanding is valid or not from the data. The starting point, guys, when you switch to the Power Query view, is keep in mind, this is actually the distribution of each column here can be very, very helpful in your exercise when you make the decisions about splitting the data. It can really be helpful. Just keep in mind, the distribution that you see here at the top of each column is not a true representation of the entire table. It's actually based on the first 1,000 rows only by design. So how to switch actually this view to make it like meaningful or representing actually the entire table is to go here at the bottom left. I hope you covered that already in the Power Query sessions before, Power Query editor session, and switch that from column profiling based on top 1,000 to column profiling based on the entire data set. Then you have to wait a little bit because now it's parsing and processing actually the entire table instead of the first 1,000 rows, which is good. Let us deep dive into some areas here. Sales order ID. Let's start with that one first. How many records do we have in this table? It's listed here. The count is here. 38,728 records. How many distinct values is the same number? How many unique values is the same number as well? So what does this is telling me basically? If you have a distinct number and the unique number are the same, what does this mean, guys? So what is the difference between distinct and unique first? Can someone tell?
Your question again.
Sorry, say it again.
Your question again.
Yeah, but what is the difference between a distinct and a unique?
What is the distinct? What is the difference between distinct and what?
And unique. Those guys, those two distinct. and
When
unique.
you are talking, but probably there's no more difference between unique and distinct. Distinct, the term distinct and unique. Probably you want to eliminate repetition when you want to get a unique value or a distinct value. You don't want the repetitions to occur in your column. That's why
Yeah, okay. So when we see the
aggregating.
same number, distinct and unique, so as someone said in the chat, that's actually suggests that there is no duplication. So that's like what? When we have no duplication in a column, what is this column technically should be? There is no duplication, it's uniqueness. The uniqueness is there. So what is this table should be called? Yeah, whoever is raising hand, please come off mute and talk. Fully well? Well, I'm not sure if I'm pronouncing your name correctly. Did you raise your hand? It means no duplication in the chat. Okay, but do you want to talk or come off your mute? Okay, if not, please put your hands down. So yes, it's actually yes. If you have those two numbers, that strongly suggests this is a unique record, and there is one record only for every single sales order ID. Perfect. So that means automatically that's the primary key for this table. Perfect. If we switch here to this view, for example, or let us go to another view, product ID. I think that can be a good explanation. So in this case, guys, how many records are we dealing with in this table? How many records? The number is here. The count is here. How many records? 38,728. How many distinct values that we have out of the 38,728 is 2,516 distinct value. And the unique is 1. Can someone again explain to me what is the difference between those two numbers? What is this number representing and what is this number is representing?
So the unique is numbers that do not repeat.
Yes.
The distinct is numbers that repeat, but we only count one time.
Exactly. That's exactly. Thank you. Yes, exactly. So in terms of the total number of products that were used in this particular column, this is 2,516 products. Some of them, they were listed more than once, and some of them are listed once. Based on the unique number here, just one particular product was listed there once. It was sold once. Out of the 38,728 records, there is one product that was sold once according to this data set, just once. All the other products were listed more than once. But if we take a unique list of those products, That's the 2,516. So if we envision now a new table for the product, we should have 2,516 record in that particular table. Okay, so let us now jump to some extraction. So my suggestion is in the sales table, keep the sales table as a source as is. Okay, then we start to actually move to some of the information that we need to extract from this to start creating the dimensional model out of it. So the starting point is, first of all, there are two options here, either duplicate or reference. The difference between duplicate or reference this table is basically duplicate. Any transformation steps that you made here and the source will be duplicated exactly. And if you choose the duplicate table, if you reference, you start with the endpoint where the sales table is there, and you start referencing from now on. With the reference option, if you make any changes afterward in the base table, it will be reflected also on the downstream reference table if you choose the reference option. So in this case, instead of duplicating actually the table, I'll just go ahead and reference this table. Okay, so I'm referencing this table. I'm as if I'm creating a shortcut for the sales table with another name now. So let us rename that table now to call it the fact sales. Okay, I'm keeping the source as is. That's my suggestion. Fact sales now, we will start to actually go and choose the column and eliminate anything that could be related to any of the dimensions. So that's our opportunity now to eliminate the records that is related to the dimensions here. Okay, let us decide actually what will stay and what will go. Sales orders column will have to remain because this is actually a fact key. This is the key for the fact table. Country, I think Benga or someone else suggested actually to have a country as a separate table or separate dimensions. But the reality is, if I go here through all those list of columns, I'm not seeing any other geo information about the country, right? So it's still okay to keep it as a separate dimensions, even though it's just one column. Or we are not sure also if the country here can be either associated to the customer. It can be technically measured to the customer. That's a possible scenario. Or it can be the country of where the sales transaction happened, where it can be associated with the store. So either one, we haven't decided yet. So I'm going through now with you through an exploratory stage because still I'm not certain about certain columns where they will eventually end up. But for me, country for now can be possibly still can be a standalone, but I don't see any other columns related to any geo information here. That's why I suggest actually to keep it either with the customer dimension or the store dimension. We will make the decision later, but either one, either options is not effective. So we will ignore that. Order date, guys. Is it a fact attribute or a dimension attribute? Is it a fact column or a dimension column? Can someone tell me? Please come off mute. Tell me. Order date. Is it a dimension information or a fact information? Dimension of what? Which dimension?
Dimension.
Yeah, but which dimension do you want to put the order date?
Date table.
Yeah, okay, but we haven't created the date table yet, but we need a relationship with this column. So it is the date of the transaction itself, because even if we create a date column later on, we need to link it with that date. So order date has to remain as a fact column, right? Because it's a fact information, right? It's not a dimension by itself. Later on, we will, when create a date dimensions, yes, we have to link it with the order date to get more attributes about the order date. But the order date itself has to remain in the fact table because it's technically will act as a foreign key with the date dimension of. Make sense? So it has to remain in the fact table, because if it remains from the fact table, how else you will associate it with the date dimension? There is no other columns actually to associate it with the date dimension. Okay, I hope that makes sense, guys. Okay, sales channel code. Where else do we have sales channel? Do we have channel? I don't think we have a channel other than sales channel code, but is this information like should remain in the fact table, or should we move it in the dimensions table? Anyone? It's a fact information. It's a fact attribute, right? Because it's a code. Code most likely, and if we have a separate table for sales channels, it has also to remain in the fact table, because that's is going to be the foreign key in the fact table, right? I'm not sure if we have another attributes or not, but definitely that's is a foreign key here. Product ID, similar to the sales channel code. It's also a fact information, because that's the foreign key from the fact table from the foreign key from the product table as a dimension in the fact table. Style name, that's attribute. So style name will belong to one of the dimensions. We will decide later which dimension this will go to. Customer account number. Of course, this is a foreign key as well. It's a primary key in the customer table, but it has to remain in the fact sales as a foreign key. Store key. Okay, store key. And again, key has to remain as a foreign key in this table, in the fact table. Remember, we are building now the fact table, right? Product label. Is a product label a fact attribute or a fact column or a dimension column? Product label, product description, manufacturer brand name, class, color, stock type. All of them, do you think they should remain as part of the fact table, or they should be pushed to one of the dimensions?
Dimensions.
Yes, excellent. So I'm not going to check any of those, because those are classification, like attributes. Product table, product label, proper product description, manufacturer, brand name, class, color, stock type. All of those guys are attributes to describe the product further. So I'm not going to check any of them. Okay, the units. This is the unit sold, basically, or the quantity sold. So is it a fact or attribute information?
Fact.
It's a fact, exactly. So I'll take it. Sales amount. Is it a fact or dimension? Fact. Excellent.
Fact.
Satisfaction score about this transaction. It's either this transaction was satisfactory to the person who purchased it or not. So it's a low or high score or label about this transaction. So is it a fact or dimension? It just has low or high based on this particular transaction.
It's a fact table.
Say it again.
It should be in the fact table.
It's a fact table. Yes, it's a fact in piece of information. Yes, it will remain here. Subcategory and category and sales size and product name and sales size sort. All of those are factor dimension.
Dimension in the product table.
Yes, excellent. Unit cost and unit price.
Fact.
Okay, think again. That can be debatable. Unit cost and unit price. There could be two scenarios here, guys. If the unit price varies from a transaction to another, it varies from a transaction to another, it has to remain in the fact table. If the unit price is consistent across the board for every single product, both of them are consistent and they don't change, that's technically a dimension attribute. It has to go through the product table. So I'll go with the assumption now, they don't change. I'll just go, I'll validate my assumption later. I'll just go with this assumption now. Okay. So I leave that for the product unless it's proven incorrect, this assumption. Sales tax, is it information associated with the product or associated with the sales transaction itself? Is it fact or dimension?
It's in fact.
It's a fact, exactly. Freight, is it fact or dimensions? The shipping cost. It could be a fact or
It should be in
dimensions,
fact.
we don't know, but let us
It should be
assume
in
that
fact.
it, sorry?
I said it should be in fact table since you
It's
don't
a,
have anything concerning
Yeah.
shipping.
yes, it's a fact, yes. Okay, and purchase again, is it fact or dimension? Let's go with the assumption it's fact now, so we can avoid any more confusion. Okay, so here, as you see here, I made those decisions. Some of them are very certain, and some of them I am still uncertain whether I made the right decision or not. But let us proceed now and see how the fact table will look like. Okay, great. So switch that. So I am now moving toward more of a simplified version of my data. So this is the fact table based on those assumptions. Okay, let's go now and start building some of the dimensions as we discussed earlier. Again, the starting point, I'll start with the base table. Right click, reference. Then go and choose column. I'll start actually with the first dimension here because I can see the store here. Store. Because I see store key here. First of all, I need to remove everything else. Then I started to actually to construct the store dimension. What is the table here associated with the store? There is a store key. Okay. Do we have any other columns for the store? Do you have any other column for the store, guys?
Entry, maybe.
I'm not seeing anything. So the decision here, which is again, I'm going through the same exercise. The decision here, do we need to create a separate store table as a dimension where we can capture more information about the store, or our report will be okay with just presenting the data based on the store key? So that's our decision. We have to discuss that with the business. If they have more attributes to describe every single store key, then we can add that. We can extract that as a separate dimension. Then we can ask the business to provide us with additional attributes for every single store. If the only column that is there is just the store key, it's useless actually to create a separate dimension for the store. So I'll ignore that. I'll just ignore that for now. Okay, I'll ignore the store. But let us go through another one, another suggestion. Let's go with the product because the product obviously is the strongest dimensions here based on what we have. Okay, let's go now, deselect everything else, and let us focus on the product now. Can someone guide me with the product? Sales order, it's not a product. Country, obviously, is independent of the product. Order date, no. Sales channel code, no. Product ID, It's a product information, right? Style name. Customer, it's a customer, so it's not here. Store, we said that it's a separate, independent, right? Because you can sell one product in multiple stores. So it's leave it alone. And you can decide later on, as I told you, to keep it as a separate dimension or leave it in the fact table. Product label, product description, manufacturer, brand name, class, color, stock type. We agreed unit and sales amount are factor information. Satisfaction is factor information. Subcategory is product related. Category, product related. Okay, product name. Okay. I'll go now with the assumption that unit cost and unit price and validate my assumption in a second. I'll go with the assumption that unit price and unit cost are consistent across the board for every single product and they don't vary from a product to another. I'll validate that in a second. Okay, anything else? Do you guys suggest actually to include it in the product table? Not, let's proceed. I'll rename this to call it dim product. Okay, let me validate now my assumption about the unit price and unit cost. If unit price and unit cost, they vary from a transaction to another, what do you expect actually the impact here on this product table to happen? If they vary, if we have one product that has more than one price or more than one cost, what do you expect that to happen? Of course, we have so many duplicate records here because we are extracting this data from the fact table. So the starting point now, because we have duplication, right? So many records are coming with the same exact information because they come from the fact table. I'm creating now a unique table for this dimension. So very first step is to remove duplicate here. We have to remove the duplicates across the board, across the entire table, right? Because if we do it here at the table level, it will go across all the entire records and remove all the duplicates here. That's good. So now we have a unique record for every single product. Let me validate now my assumption about the unit cost and unit price, right? If we have products where they have multiple units or multiple costs, we will not be in the end with this situation where the distinct and unique are identical. If the distinct and unique are identical, that means my assumption is valid. We don't have sales transaction for a particular product where the cost vary from transaction to another. Otherwise, it will be causing a duplication here. Because you can have one product with $10 and the same exact product with $5 based on some other transaction. That means when we eliminate the duplication, it will still remain twice because one record is associated with $10 and another one is associated with $5. That means in this case, unit price or unit cost has to be posted in the fact table and it cannot be part of the dimension table. But luckily in this scenario, no, if after we eliminate the duplication across the entire table and the distinct and unique are identical now, that means my assumption is valid. So the product actually, this is the actual perfect table or dimension table for the product. Okay, are you okay with my assumption or you are not sure? Okay, let's go now to another dimension and see whether we are successful or not in our assumption. Reference table. Let's go with the selection again. Choose column. And let us focus on this time on the sales size, because we identified there's a sales size here. There are two columns associated with the sales size, which strongly suggests actually to have them as a separate. What is the sales size here table? Sales size sort and sales size itself. Okay, so the sort here is an ID. It can act actually as a primary key for the sales table, size table, and it can be also a foreign key and the sales table. Okay, so let us go ahead and see how it looks like. Of course, we have to go here and remove duplicates. So we have a lookup table now with 3 records only. Sales size sort, which is 1, 2, 3, and the sales size, small, large, medium, and this dimension table. And this should be considered as dim sales size. Just let us go back again. I just want to double confirm that the sales size sort, I left it as a foreign key and the fact table. If I go here, choose dimension again, sorry, choose column. Just want to confirm. Or you can just double click here, same thing. Yes, I have to keep it here as a foreign key, because that's actually the foreign key that will associate the sales size dimension, those 3 columns, with the fact table. Let's proceed quickly with one more dimension, reference. This time I will focus on, let's say, the customer table. Choose column. Oh, sorry, I made a mistake. I referenced actually the fact table, which is not good. So I'll delete that. I have to reference my base table, because every time I have to reference my base table, which has all the columns. This time I will focus on the customer dimension and see how it will look like. Select all. Okay, customer account number. Okay, is there anything else about the customer, guys? Do you suggest anything else about the customer from the columns that we have here? Anyone? Remember, we were having debate about the country. Is a country as a separate dimension? If we have enough information about some other aggregation or not, or can we keep it as part of the customer? Is the assumption here, is this the country of the customer? Or is it the store country? So let us now go with the assumption that this is the country of the customer, and let us validate that and see how it will look like. Okay, cool. So then customer. Then similar to the other one, we go ahead and remove duplicates. Switch that to this guy here. And let me validate my assumption now. Do we have a unique country per customer, or the customer can exist in multiple countries? Because if that is the case, that's a wrong assumption here. We have to remove this column from this table if it is causing duplication. Right? I remove duplication as a combination between the country and the customer ID or the customer number. But now we are not sure if we have one customer that does exist in 2 separate countries or not. Because if that is the case, that means my assumption to include the country as a field or a column in the customer dimension was a wrong assumption. Let me validate that now. Let's go here. Excellent. So all the tables are aligned now. That means there is a uniqueness between the customer and the country. So my assumption is valid, right? Because again, all the numbers are identical. Total customer, 9,468. Distinct is the same number and unique is the same number. Perfect. That's my assumption is good. So I'm okay with my moving forward with my assumption here. Okay. The last one, last dimension is reference again. I think the channel. I think we left the channel behind us. So choose column. Deselect all. We talked about the sales channels. Okay, we have a sales channel code. right? Do we have something else? Let me go through another assumption. How about the country? If I made a decision here, if the customer or the country was not, it doesn't belong to the customer, can I associate the country with the channel? Let me go with this assumption again and see what is the relationship between the country and the sales channel, because I don't see any other columns here about the channel. Let me go with this assumption and I will validate it in front of you now. Let's go with this assumption. Okay, switching out now to the entire view. And similar to what we usually do is remove duplicate. Okay, cool. So we remove duplicates. Let us go with the sales code now. Okay, so was that a good decision actually to consider the country as one of the columns in the sales channel dimension table or not? Was it a good assumption or a wrong assumption based on what you see here? Anyone? What is the driver? How would we know that if the assumption that we made is a good assumption for the dimension table or not? What is driving this decision to say, okay, this is good assumption or not a good assumption? We talked about it several times before. This guy here, the customer. Sorry, say it
Because
again.
you don't have unique values, right? So
Yeah,
it doesn't
exactly.
work
See,
as-
that's assumption is perfect assumption. All the numbers here are aligned. I'm now mistakenly or intentionally made a decision now to assume the country is one of the attributes of the sales channel. But what is the result now? Was my assumption is a good assumption or a wrong assumption? Based on what you see here, based on those three values. Total count is 12, distinct 2, and unique 0.
Yeah, it doesn't sound right because it doesn't seem right because you don't have unique values. So it doesn't
Excellent.
work as a primary key, right?
Excellent. Excellent. Thank you so much for paying attention to all of that. So that means I made a wrong assumption. So I should actually go ahead and remove the country here because it doesn't technically belong to this dimension, which is actually, it was proven to be correct here in this scenario because, again, if you go to the column here, the customer account, all the numbers are aligned. That's identifies uniqueness. This will leave us here with this column only, which is now we just have two values, I and S. Okay, so that's them channel, but it has only two values, right? Which is I and S. But some people, they can ask a question like, what is I and what is S? Okay, basically that's our opportunity now to add more, decode some of the codes that we have in our model here, because we don't have a description of those two fields. Now, since I decided actually to remove them to become a dimension, that's our chance now to provide a description for those two fields. Okay, so how to do that? You can go here, if channel code equal I, that's actually is internet. Or if the channel code equals S, that's a store. So I provided, actually, I decoded the two values. And here, just to be safe, if any value in the future that is not either I or S, we'll just call it other. Okay, that's it. So I'm adding additional attributes as a descriptive attributes to those codes because we don't have a description for them in anywhere else on the model. That's it. That's basically it. So we ended up from one centralized table, denormalized with all the information, to a fact, which is a sales table, and a bunch of dimensions around it. Let us go now ahead and see if we did a good job or not when it comes to the data model. But before, first step, before we proceed further, you have to disable actually this table from being enabled in load. because I don't want that to be part of my data model anymore. Because if I just click close and apply, it will go with my data model, but I don't need it because that was my source. That was my sales base table. So I'll just go ahead here and disable enable load. Keep include report refresh because this is still source table that feeds all the other dimensions and facts. That's the source, but I just deselect the enable load. That's it. So if I just now go ahead here, close and apply. See what happens now from this view, which is one table view. See how many tables we will end up now with. Give it a chance to load. Excellent. So the main table, the main sales table disappeared, and we have now a bunch of dimensions and facts. Let's switch the most important thing. Switch now to this beautiful view. Excellent. See, it is aligned already with our understanding of the dimensional modeling, the fact and dimensions. The sales fact table is in the middle, which is great, surrounded by a bunch of dimensions. And all the relationships were automatically detected. That means we haven't missed anything from a primary key side and the foreign key side. So all the tables are linked automatically, and Power BI was smart enough and intelligent enough to sense that all those columns were identified as a primary key in the dimensional side. Also, they do exist as a foreign key in the fact side. And this is actually the perfect star schema dimensional model. Of course, what is missing is the date dimension, and we can create a date dimension table easily. Yeah, I see a question, so go ahead, please. Aslant?
Yes, that's right. Sorry, where did you click to identify the relationships?
No, I didn't click anything. I didn't just, I just switched from the table view to the modeling view. Power BI automatically detected the relationships. I didn't do anything.
Oh, cool. Great.
Once the columns are matched already from the dimension side and the fact side, because the dimensions, every single column here, guys, if I hover over it, okay, let me zoom in a little bit. If I hover over any relationship here, the column match. This is a primary sales channel code, is a primary key in the dimension channel and the foreign key in the fact table. Any relationship, when you hover over it, Power BI automatically was smart enough actually to identify this relationship for me. In case, if you have any missing relationship in Power BI, since you asked this question, in case the relationship was not automatically detected, in case, I'm just saying, in case, you just need to go here, drag and drop, and it will just give you this view just to confirm this is the column from the fact table and this is a column from the dimension table. And it will tell you this is the cardinality level, blah, blah, blah. Then you can just go ahead and just click yes, and the relationship will be built for you. Also, you can go here and manage relationship, and there is an auto detect option here as well that can go through the entire model and identify the relationship for you. And as you see, all the models here or all the relationships are perfect relationships here. Fact and dimensions, one to many, as we explained earlier, one from the dimension side, where every single record here is unique, and many from the fact side, where we have multiple records on the many side in the fact table. Then you can just start now, go ahead and play and interact with different dimensions. Of course, you can create a dimension, right? So the simplest way is just to go in the modeling, new table, then date or dim date. Okay. Go to calendar. Just simple, huh? I'm not saying this is the right way to do a date dimension, but this is the simplest way. Now we have a date dimension. Just make sure that you go here, mark this table as as a date dimension and choose the date column. Save. Go ahead. Go back again to this guy here. And now, just now, date and order date. You have to build the relationship. Excellent. So we have a date dimension now associated. And of course, in the date table, you can add more attributes. You can split now the year, the month name, the week number. You can add any additional attribute here to the date dimensions to allow further time intelligence analysis based on. Then you can just go ahead now and just play with the data. So like for example here, I think we have a year function, if I'm not mistaken. I'm just extracting the year here. Okay, so let's go now, year. And let's switch that to line chart. Then sales amount from the fact table. Of course, you need to create explicit measure. I think Panga will talk to you about that later on in the next sessions. But if we're fact table, you need to create explicit measure. But for the sake of simplicity, now we'll just go ahead with this column, just drag it and drop it, which is not a good practice, or not the best practice, I would say. And let us take one value from the product dimension and use the category Okay, so I'm merging now different dimensions together. See how many tables I hit now. So my chart is based on 3 dimensions and 1 table and 1 fact. So it's actually technically linking all those to make sure that all my relationships are working fine according to the star schema dimensional. I hope you guys learned something new, how to convert a flat table now from a just denormalized flat table where we started to a nicely done perfect star schema dimensional model here, where we have the fact in the middle surrounded by all the dimensions here, which is again, go back again to where, who, why, what, and so on. Any questions, guys?
Guys, if you have questions, please ask.
Yeah, please go ahead. That's your chance to ask.
Modeling is something complex sometimes. You need to be able to master it very well. So if you have questions,
I totally agree. It needs some more time to digest it, and feel free to ask if you are uncertain about any of the things.
Yeah, can we have the data with the video on time so that we can practice, just like you said, we need to practice so that we'll be sure that we have actually gotten it. If we can have the data and some other one that flat data so that we can deal with the modeling very well.
Sure. And by the way, there are plenty of publicly available open data, guys. So if you can pick and choose any data that can make more sense to you, feel free, because there are so plenty of denormalized data and so many publicly available websites. But I'll definitely pass this piece of the data source. You are talking about the data sets, right? So I'll pass it. Yeah. Okay. Aslant.
Yes, one question. You have this flat table from a CSV file, right?
Yeah, it doesn't matter. CSV, Excel, it doesn't matter.
Yeah, but the thing is, when you are creating these dimension tables, you are creating new files as well? Or you are creating just a big Power BI project?
So
do you know what I mean?
No,
I'm not. You are creating
sure.
different sources when you're creating these dimensional tables?
Okay, let me go back again. So this is where I started, right? This is my source file, right? This is, if I go here, source. Okay, so that's my sales table. Okay.
Yeah,
So
that's right.
it's just happened in an Excel file. Okay. So I ingested that. I ingested that file, and this is my master file. Okay. This is ingested now in Power BI side, right?
Mhm.
Inside Power BI, I started actually to create those shortcuts. Consider them as a shortcut. Technically, they are not, but let us, for the sake of simplicity, I reference the fact table to reference this one. The dimension table is dependent on this one. And this dimension table is dependent on, because every single one of those, the starting point was to reference the sales table. So the data was loaded once in the sales table. After that, I just started to create subset of the base table. Subset in terms of columns and rows, because every single table here is representing subset of my base table, which is the sales table. The fact here is subset in terms of the columns, because not all the columns are in the fact table. I eliminated some of the columns because I know that they eventually go to the fact, the dimensions. Here, I eliminated also some of the irrelevant columns, but I also removed duplicates as well. So that means this is a subset only relevant to the product table. This is a subset only relevant to the sales size, just 3 records. This is a subset only relevant to the customer, and so on. So every single table after that is just subset view. It's like creating a view on the top of a table in a SQL Server, for example. So where is the table? That's my table, where all the records and all the columns are there. Here, consider this as a multiple views on the top of that table.
Okay, got it.
You got
Thank
it?
you.
Then now everything here is stored inside Power BI. So when I save this file eventually in a PBIX file, now it's stored in the PBIX file. Has nothing to do with my source. My source is still there. My source is still Excel file that has all the denormalized data in just one table called sales table. I didn't touch the source. All the transformation happened on the Power BI side. Again, as
Okay,
if you are
cool.
creating multiple views on the top of the tables in the SQL Server, if you come from a SQL Server background. I hope that
Thank
answers
you.
your question. Okay.
Yeah, absolutely. Thank you very much.
You are welcome.
I have a question again.
Sure.
Yeah. So with this that we did here now, it means that it's possible for us to go and create a view in our database, maybe SQL Server
Yes.
database.
Yes. If you come from a SQL Server background, all the exercise that we did here in Power BI technically can be simulated in multiple ways in the SQL Server. It can be done as a data warehouse technically, because in a real world enterprise scenario, all the transformation that we did here, technically it should have been done in the data warehouse when we go and build the dimension model in the data warehouse. That's the ideal perfect scenario. The other scenario as well is we can create a bunch of views on the transactional table to simulate the fact and dimensions. That's another opportunity as well. But the assumption that we are working here is you have no control over the source. The source is it is what it is. It's not a perfect scenario. You are given the data and you have no control over the source. You have no influence. You don't have any recommendation for it. It's your responsibility now to take over this work and do the modeling thing inside Power BI. That's the assumption that we are working on. Is it? Can we do it? Yes, we can. We prove that we can do it in our end. Is this the ideal perfect scenario in enterprise organizations? No. Because they have to build that in the data warehouse technically, or build a bunch of views, as you said, or there could be multiple ways of achieving the dimensional model. But here, the assumption here is how to use Power BI as a complete self-service tool. If you have no influence and no control over the source, and the source, it is what it is, it's just sent to you, and it's your responsibility now to handle it properly in your. That's the assumption we have. Power BI can do it? Yes, we proved it. That makes sense? That answer your question?
Very well, very well, very well.
So here we are just demonstrating, guys, the self-service capabilities that we have in Power BI. It's a very powerful tool to allow us to do what we want on our end. Enterprise is a completely different discussion, because that has so many other constraints and best practices, etc. But if it is just small project and small exercise, and the data was sent to you in a denormalized way, that's how you use Power BI to simulate and build a dimensional model inside Power BI? Good question. Aisha, can you provide an example of when you would need to duplicate or our source table instead of referencing it? If we duplicate it, will the relationship still detect? Yes, at the end result, it doesn't really matter. I just wanna clarify something here about the duplication versus the reference. Let me do something here. Let me do this exercise here. If I go here in the base table, because remember all those tables were referenced based on the base table. Let me do an exercise here. Let me do a scenario here and see how it behaves differently. If I apply a filter here, what do you expect to happen? Or let me apply a filter for something else. Let me filter one particular ID. Okay. A mistake, intentional, whatever. What do you expect to the impact for all those reference table here on the top of that table? What do you expect to happen?
It will have affected the source.
It will affect what the source is. I'm affecting the source, but down the stream table, the reference table. What
Yeah.
do you think? Huh?
Yeah, we have. It's as good as probably we drill down this all this view that we newly created.
So you expect that it will impact actually all the reference table.
Yeah, yeah.
See?
That's,
See? So I applied the source once. Any manipulation or transformation that is impacting the source, it will be automatically consumed all on the downstream report. Tables, all the downstream tables, which is referencing actually this one. Okay, that's the reference. So it has pros and cons. So the reference is just referencing the tables based on what we do here as a while. If we choose the duplicate, let me go through this exercise instead. Duplicate this time. So duplicate is just creating another duplicate. It's called sales2. It's a duplication. But let us apply now the same filter and see if it will behave the same or not. Okay, what do you expect to happen in the sales2 table, which is a duplication of sales1 table? What do you expect to happen? No dependencies.
if because
No dependencies.
because the first
Sorry, say it again.
because the first source table, because the first sales table is a source to the duplicate, it will still affect the duplicate, except if like the effect that you did to the source table, which is the sales table, if you go to the duplicate, you did it to the duplicate.
Exactly.
And
so it's creating a different copy of the same table, completely independent from the first table. It copies all the steps before, so it copies all those steps before the last action. So we have an identical copy of all the previous steps. But there is no linkage anymore. Whatever I do here will not impact the duplicate one, but it will impact definitely the referenced one. So in all the tables, the other one is the referenced. Not sure why it's not hitting. Let me refresh. So it will impact the reference table, but it will not have any impact on the duplicate table. That's from how it works here in the Power Query Editor. But if you move to the push everything there in the dimensional model and relationship, it has no impact whatsoever on the modeling side. It will behave exactly the same thing from a modeling perspective and relationship and detecting relationship, etc. The only reference, as I told you, I just demonstrated to you what is the difference between if you reference table and just apply any additional transformation steps here, all the dependent referencing table will be impacted by this transformation. while the copied one or the duplicate one will not be impacted. It's independent from the other one. I hope that makes sense and answer your question, Aisha. You are welcome. Any other question, guys? Did you learn something new? Are you a data modeling expert now? Can you apply for data modeler job posts now? Okay, good.
You want to become a data modeling expert in 2 days.
Yes, exactly. Actually, it's not technically 2 days. It's just 4 hours, 3 hours, actually, 3 hours.
Yeah.
1 hour last week, 1.5 hours last week, and 1.5 hours this week. So
Yeah,
in 3 hours, you
yeah.
become a data modeler, guys. You can apply for data modeler job.
Okay, guys. So truth of the matter is, all of these things that you're doing in class, if you don't go back by your own, to do practice again,
Yes.
What Ashraf did for you guys is this is just like a sample of what you see in the enterprise level, right? There are a lot of use cases. There are situations whereby you can have a denormalized table like he give you, and you have to normalize it. You have to break it down into factor and dimensions. There are situations whereby you have a data warehouse already that has all of those things. There are sometimes that even what some companies call data warehouse is just a copy of their OLTP systems, and you have to write a lot of queries to join and join and join to be able to complete all the business entity that you are looking for. So, guys, it's just just an example out of many examples. So, you guys, you have to go on your own. You have to practice it. You have to rewatch the video. If possible, even if you need to rewatch, even if you need to watch other people's video on YouTube for you to actually understand the concept and see different kind of case scenarios. That is how to expand your knowledge base, right? Because as a community, we can try our best. We can teach you, to the best of our ability. But if you don't go on your own to go and practice and to read more, you might not be able to, understand fully. So I think you wrote a book, right, Ashraf? I think you have a book
Yes.
somewhere.
Yes,
So can
I
you tell
wrote
us about the book, please?
Yeah, I wrote 2 books actually about Power BI with other MVP folks. But I just want to echo what you just said, Pinga. Whatever we are teaching you guys is as if we are just teaching you how to fish, but you technically don't have the fish until you go and fish yourself, right? We are just teaching you the principles, the concepts, how to do it, but technically you don't have the fish yet. I just showed you how to fish. But to have your own fish, you have to go and fish yourself, right? Similar to that, I'm teaching you the principle of swimming, for example. Are you a good swimmer now? No. You have to go and practice, right? No matter how much time I swim in front of you or give you some directions or guidance or instructions how to be a good swimmer, you will never be a good swimmer until you go and practice yourself. You have to prove it yourself, right? So the practical side of it is extremely important. That's how I learn. That's how anyone in the industry learn, is you have to get your hands dirty and actually work on use cases. There are plenty of sources, guys, when it comes to open data. One of them is actually should be listed here. If you go here, get data, I'm not sure if you come across that before. I think online service. See data world here. See, get data world. So you can connect to the data world here, and you can see plenty of open data sources there. Okay, so go to their website, like World Data, and you will see so many things, so many data sets are publicly available there. Also, the Power BI has also already sampled data set as well, right? So if you go, I hope you had a chance also to explore that. So if you go here to the Power BI, blank report. Here, use sample data. So basically, if you click here, load sample data. Yeah, see our financial data here, which is obviously the normalized table, obviously. Like it's one table, right? So you can have that as a starting point for yourself to check as well. You can go through the same exercise and see if you have any opportunities here to identify the facts and dimensions from what you see here. See, we have segment, we have country, we have product, we have discount band, we have units sold. See, this is exactly similar scenario. Manufacturing price, sales price, gross sales, discount, and so on. So see if you can differentiate actually month name. See, this is month number. Okay, date, month number, month name, and year in the same exact denormalized data set. Is this a good place? Do you agree that you should keep those 5 columns or 4 columns in one table? Huh?
No,
Of
no,
course no.
it shouldn't be here.
Of course no. Of course no. You can eliminate all of that and just push that to the dimensional table, right? Similar to that, the country, you can add the country and you can add additional information, guys. When you split the column, of course, you can also, since you have a separate table for the country, for example, maybe you can add more information at a higher level than the country. Maybe you can extract the continent from the country. So you can go through a similar scenario. Okay, if we have the lowest level of granularity when it comes to the location is the country. Is there an opportunity to roll it up to a higher level? Yes. So maybe you can divide those countries to a certain regions or areas or continent. So you can aggregate the data to a higher level. You cannot go lower because you don't have in the fact table anything lower than, more granular than the country, right? But if you have the country as the lowest level of granularity, of course, you can add additional attributes. You invent them to add additional attributes to aggregate the data at a higher level. Lower level, no, you cannot go lower. You can go higher, right? So I hope you guys enjoyed this session, and yeah, looking forward to hearing back about your successes, and stay in touch, guys. You can find me on LinkedIn, connect with me on LinkedIn. If you happen to be in Toronto, please come and join our user group events, and all the best to everyone.
Thank you so much, Ashraf. Thank you so much. God bless you. If you are in Ontario Axis, if you are in DCA, if you are in downtown Toronto, please join the Toronto Fabric and Power BI user group. And it's physical. I think you guys always have your meetings inside the Microsoft office in downtown, right?
Yes, exactly. Yeah.
Please, guys, if you are in Ontario, please join. Meet people, connect with people, learn from them, learn from their experience, and we all grow together. Thank you, everyone, for today's class. Thank you, Ashraf. Thank you
I
so
think
much.
there's one last question from Love.
Okay.
Yeah, just I want to make sure that we address.
Yeah. Sorry, I just wanted to confirm. So the lower level of the country, so you're talking about, let's say, for example, states, right? But since we're not given state, the country is the lowest level. Then we can go higher to like
We
continent
cannot.
or region.
Yeah, if always you are driven by the lowest level of granularity in the fact table. If the information or the transaction is captured at the country level, you cannot go lower than the country level because you don't have any transaction associated with a specific city, right? We don't.
Yeah.
We don't know which city in Canada, but for sure we know that Canada belongs to North America. That's a fact. So we can have a higher level than Canada, which is the continent, because Canada belongs to North America.
Okay, so that means that higher level, is it that we can add it to fact table, or we can just create a new table and then connect it to the relationship using country unique ID or something like that?
Yes, you're always driven by the lowest level of granularity in the fact table. right?
All right.
You
Okay.
can
Thank
add more.
Yes, sir.
When you push it to the dimension, you can add more. That's your opportunity to add more attribute. You are describing Canada further. You are describing Canada further. Like, for example, you can say, okay, what we know about Canada. Ottawa is the capital. Okay, we can add attribute to say Ottawa is the capital. We can add another attribute, the English is the official language, the Canadian dollar, blah, blah, blah. So we can add additional attributes about what we know about Canada, but we cannot go any lower than Canada because we don't have the fact transaction associated with anything lower than Canada. If we have it at the city level, definitely we can roll up the city at the province level, then at the country level, etc. So you can always go up with additional information, but you cannot go down. If your data is at the lowest, that's why we always encourage people when you design your front-end system, capture the data at the lowest level of granularity, because rolling it up at a higher level, it's easier for me. But pushing it down more granular, I don't know. If the data was not captured or the data capture system was not designed this way, I cannot know which city in Canada the transaction happened. I have no information, right? So that's why we always
Yes, please.
encourage people when they design the front-end application system, try to capture the lowest level of granularity as much as you can. Go even at the postal code level, at the address level, because I can easily roll that up. The data is fact. Anything above the postal code, I know it. I can know it. But anything lower than the country, I have no clue. Make sense?
Oh, okay. Yes, please. Yes, please. Thank you.
You are welcome. Okay, great. Great question, guys. Keep learning, keep enjoying, and I wish you all the best with the rest of your workshops, and all the best, guys. And thanks, Bing, again for inviting me, and thanks everyone for your time. Take care, guys.
Thank you very much, Ashraf. Thank you, everyone. See you guys again next week. Thank you.
Thank you.